friends, we are going to discuss about the MCQ question of chapter 14 oscillation, because the most of students suggested that we have the difficulties in short question, that means in MCQ question. For that purpose, for preparation of the unit test and also the internal exam for January month, we are taking some MCQ question and also we give the hint how we solve it, right? Okay, now to solve the MCQ type question of the particular question, first we must be familiar with all the theory of this chapter and what are the equations already we learned during the theory. Because in competitive exam like as the NEET, the syllabus is also 11th and 12th standard. The most of the questions in NEET are asked on the basis of theory and also very short numerical. That is also depends on the equation already we learned in theory portion. Actually, that is the application of the equation whatever we learned during the theory. For that purpose, we are considering some numerical, and I give the hint to solve this numerical. Okay. Now for chapter 14 oscillation, already we learned in chapter 14 oscillation, simple harmonic motion, simple harmonic oscillator. What is the equation of the velocity and acceleration of simple harmonic oscillator? In which condition the velocity becomes the maximum, or at which position the acceleration is maximum? What is the kinetic energy, potential energy and total, that means the mechanical energy of simple harmonic oscillator? And what are the equations of differential equation for simple harmonic motion, damped oscillation and also the forced oscillation? Right? So keep in mind these points. We are going to discuss about some MCQ type question. The most probable question in this chapter depends on the simple harmonic motion. So first question, amplitude of simple harmonic motion particle is 4 centimeter. At what distance from the mean position will the potential energy and kinetic energy becomes the equal? Here the amplitude for the particle performing the simple harmonic motion is given. A is equal to 4 centimeter. We have to find out the position x at which the kinetic energy and potential energy becomes the equal. Already in theory we discussed, when we discuss about the graph of the energy versus distance from the mean position, the y or the x is equal to plus or minus a upon root 2 distance. The kinetic energy and potential energy becomes the equal from the graph like this. That is the total energy. That is the equation, graph of the kinetic energy. That is the graph of potential energy. That is the graph of kinetic energy. Okay. So these points at which the kinetic energy and potential energy becomes the equal. So how we can obtain it? So from this equation, potential energy is equal to kinetic energy. Equation of potential energy is half kx square. And equation of the kinetic energy is half k square minus x square. Here half k cancel, therefore x square is equal to a square minus x square. Take this x square this side, therefore 2x square is equal to a square. Therefore x square is equal to a square by 2. Therefore, x is equal to plus or minus a upon root 2 distance from the mean position. X is equal to 0. X is equal to 0. Right. Now the value of a is given. That is the 4 centimeter. Plus or minus 4 upon root 2. Therefore, plus or minus 2 root 2 distance from mean position. The kinetic energy and potential energy becomes equal. Understand or not? So already we learned this gap of the energy versus distance. There is the x is equal to 0 mean position, and there is the x is equal to plus a maximum, and this side x is equal to minus a. These are the amplitude. There is the graph of kinetic energy, and there is the graph of potential energy. At these 2 points, the kinetic energy and potential energy cross each other. That means the kinetic energy is same as the potential energy. So here, amplitude of the simple harmonic motion is given the 4 centimeter. We have to find out the position at which the kinetic energy and potential energy becomes equal. So we compare the equation of the kinetic energy and potential energy. Potential energy is half kx squared. Kinetic energy is half k into bracket s square minus x squared. Half k cancel. Therefore x square is equal to s square minus x squared. Take this x square this side, it becomes the positive. Therefore 2x square is equal to s square. Therefore x square is equal to s square by 2. Taking the square root, x is equal to plus or minus a upon 2. A is given 4. Therefore at both sides, from the equilibrium position at 2 into root 2 distance centimeter from the mean position, the kinetic energy and potential energy becomes equal. So very easy MCQ question. Okay, now next. The maximum velocity of simple harmonic oscillator in terms of the mechanical energy and mass of oscillator M, we have to derive. So the maximum velocity of simple harmonic oscillator in terms of mechanical energy. So we know that E is equal to half k square. But we know that k is equal to m omega square. Therefore, total energy is equal to half. Instead of the k, I substitute the m omega square and s square as it is. But we know that a into omega, that is the velocity. But a into omega is equal to velocity. Therefore, E is equal to half m v square maximum. Right? We require the equation of the v square maximum, V maximum, is equal to 2E upon M. Therefore, V maximum is equal to under root of 2E upon M. Right? Again, the total energy, maximum velocity of simple harmonic oscillator, we have to obtain in terms of total energy of the mechanical energy and mass of simple harmonic oscillator. Therefore, the total energy equation half k square, but k is the force constant, k is equal to m omega square. Right? Okay, m omega square substituted here. Therefore, total energy is equal to half m omega square into s square. But the a omega is equal to v. Therefore, instead of this, we can add the v square. Therefore, E is equal to half m v square maximum. Therefore, v square maximum is equal to 2E upon m. Therefore, v maximum is equal to under root of 2E upon m. Right? Now, what is the displacement of the body in simple harmonic motion when the potential energy becomes the 3 times than the kinetic energy? So potential energy is 3 times more than the kinetic energy. So we can add potential energy is equal to 3 times of the kinetic energy. Now already we know that what is the equation of the potential energy? Half kx square is equal to 3 times kinetic energy half k s square minus x square. Half k cancel. Therefore, x square is equal to 3 times s square minus x square. Open this bracket. Therefore, 3 s square minus 3x squared is equal to x squared. That is the same as 3x squared taken in this side. Therefore, 4x squared is equal to 3s squared. We require the position or the distance from the mean position, that means the value of x. Therefore, x squared is equal to 3 by 4 s squared. Taking the square root on both sides, therefore, x is equal to plus or minus under root of 3 by 4 x. So, here. But the square root of 4 is 2. Therefore, plus or minus root 3 by 2. At this position here, the mean position, the potential energy becomes the 3 times than the kinetic energy. Potential energy becomes 3 times than the kinetic energy. Again, it is the same as the earlier first MCQ question. But here, the potential energy and kinetic energy are not equal. But in first question, both are equal. But here, the potential energy is 3 times than the kinetic energy. Therefore, potential energy is equal to 3 times kinetic energy. Substitute the equation of kinetic energy and potential energy. Kinetic energy, half kx squared, is equal to 3. Kinetic energy, half k square minus x square. Both sides, half k cancel. Remaining is x square is equal to 3 into bracket s square minus x square. Multiply 3 is term, 3s square minus 3x square. Take this 3x square this side, it becomes the 4x square is equal to 3s square. We require the distance for the displacement x from the mean position at which the potential energy becomes 3 times of the kinetic energy. Therefore, x square is equal to 3 by 4 s square. Taking the square root, x is equal to plus or minus square root of 3 by 4 e. So, it's equal to plus or minus root 3 upon root 3 by 2 e. Complete it. Okay. Now next, a body of mass m executing the simple harmonic motion with amplitude v. When its displacement x is equal to 1 unit, the force acting on it is b. Then what will be its maximum kinetic energy? So here the particle performing the simple harmonic motion. During the simple harmonic motion, the historic force act on the particle is directly proportional to the displacement and also in opposite direction of the displacement. Therefore, F is equal to minus kx. Here we only consider the positive or the magnitude. Therefore, F is equal to kx. Is destroying force. Now, at x is equal to 1 unit, F is given as b. Therefore, b is equal to k into 1. Therefore, b is equal to k. Historic force b is equal to k. Now, what is the maximum kinetic energy? Now, the maximum kinetic energy is half m v square maximum is equal to half k square. But the k is equal to b. Therefore, half b a square. Half b a square. That is our required answer. Because the historic force during the simple harmonic motion is F is equal to minus kx. But here we neglect the negative sign. We only consider the magnitude of force F is equal to kx. So this value of force is given the b. And x is equal to 1. For that purpose, at x is equal to 1 unit, force F becomes therefore B is equal to K into 1. Therefore B is equal to K, or the K is equal to B. Now the maximum kinetic energy, half mv square maximum, is equal to half K square. Substitute the value of K. Therefore half B square. Half B square. Now the next. The maximum stirring force of a body executing simple harmonic motion is alpha, and total energy is beta. Obtain its amplitude in terms of beta and alpha. Now the maximum stirring force. Maximum stirring force is act at end point. Right? The maximum stirring force is at x is equal to A. Therefore, F is equal to Ka, that is given as the alpha. Therefore, alpha is equal to Ka, that is equation 1. And total energy, E is equal to half K square. Half K square. And that is given as the beta. That is given as beta. Now, taking ratio of 1 to 2. Taking ratio of 2 to 1. Or in other words, we can also add beta is equal to half K into A. K is equal to alpha. So half alpha into A. Half alpha into A. Or in other words, this way, beta upon alpha. Beta is equal to half A square upon Ka. So 1 times Ka cancel, therefore A by 2. Therefore, amplitude A is equal to 2 beta upon alpha. 2 beta upon alpha. Again, the maximum stirring force is at extreme point or the end point. So, substitute the x is equal to A in equation F is equal to Kx. Therefore, maximum stirring force F is equal to K, that is given as the alpha. And maximum total energy E is equal to half K square is given as the beta. So in this equation, instead of the K, we substitute the alpha. Therefore, half alpha A is equal to beta. Or in other words, taking the ratio of 2 to 1, beta is equal to half K square upon alpha is equal to K. So K cancel, remaining is A by 2. Therefore, A is equal to 2 beta upon alpha. Now, next is the initial phase of a body executing the simple harmonic motion is pi by 4. Initial phase phi is equal to pi by 4 radian. Then, what will be its phase at end of 10 oscillation? Number of oscillations are 10. We have to find out the theta after 10 oscillation. Right? Therefore, the phase at end of n oscillation is theta is equal to 2 pi n plus phi. Therefore, 2 pi n is equal to 10 plus phi. Phi is equal to pi by 4. That means the 20 pi plus pi by 4. So take the LCM 4. Therefore, 81 pi by 4. That much radian is the phase of simple harmonic oscillator at the end of 10 oscillation. Keep in mind this equation. The phase after the n oscillation or the end of n oscillation, theta is equal to 2 pi n plus phi. Phi is the initial phase, that is given the pi by 4. N is the number of oscillation, that is given 10. Therefore, 2 pi into 10 plus pi by 4. Therefore 20 pi plus pi by 4, that means the 81 pi by 4 radian. That is the answer of our question. Now next, maximum velocity and maximum acceleration of the particle executing the simple harmonic motion are beta and alpha respectively. Maximum velocity Vmax is given as the beta and Amax is given as the alpha. What is its frequency? We know that the A maximum upon V maximum, maximum value of acceleration is A omega square, while V maximum is equal to A omega. That is the omega is equal to 2 pi f. Therefore 2 pi f is equal to A maximum alpha, V maximum beta. Therefore frequency of oscillation f is equal to alpha upon 2 pi beta. Again, the maximum velocity is given beta and maximum acceleration is given the alpha. What is the frequency of this simple harmonic oscillator? We know that the A maximum is equal to A omega square, V maximum is equal to A omega. Take the ratio of A maximum to the V maximum, A omega square upon A omega is equal to omega, but omega is equal to 2 pi f. Therefore, f is equal to alpha upon beta into 2 pi, or the f is equal to alpha upon 2 pi beta. So, very easy MCQ type question, very short numerical. If we have the enough knowledge about the theory and also the what are the equations we learn in theory portion. There is only the application of the equations. Clear?